Okay, so let's take a look now at graphing with technologies. You will still be asked to graph some of these by hand. In fact, the way your final test will be set up, there'll be a part that's a no technology part where you will be having some of these that you will graph by hand. And then there'll be a part that'll let you use technology later on, especially when we get into the stuff that we want to do with these polar graphs. Okay, so so you do still need to know how to graph these by hand, and being able to graph by hand will also help you with some of the ideas of what's going on as far as slope and area later on when we get into those questions with our polar graphs. Okay, but I do want to show you now how to graph using Desmos. Desmos is a very effective way to graph polar curves. So the command to graph something in polar curves is to use the variable r to put in our equation. So we'll just do a very simple example. The first one we did was cosine theta plus 1. So we would go in here cosine. And the theta variable is over here on the keyboard. Cosine theta. Let me make sure it's zoomed properly. There's zoom square. So just cosine theta itself, as you see, is just a circle. And then plus 1. There's our cardioid shape. Now, it's really important, though, when we're graphing things in polar coordinates, that not only do we know what the shape is, it's important to know when you get a certain part of the shape. Because one of the things we're going to be approaching in the next section is we're going to need to know where two different polar curves cross each other, intersect. And so we need to know if they actually intersect, or is it just the fact that it looks like they're intersecting? Because they could be intersecting at different values of theta, in which case they're not really technically intersecting, at least not in the polar coordinate form. So we like to be able to graph this and see the actual graph coming up. So to accomplish that, once I have my curve in there, I introduce an upper parameter, usually a, and I add a slider for that a. Now I need a to run for the values that I'm graphing, which will be between 0 and 2 pi. So I go in here on my a and I put those values in, 0 to 2 pi. And usually I set a step of pi over 12. That way it's dealing with your standard kind of 15-degree thing. And then what you can actually do then with that slider is with your hand, you can just start moving it out. Right? Seeing how the graph slowly comes about as you generate your radian modes. So you can see there we are in the first quadrant. Now we've reached pi over 2. And we can see that we're getting our little tip of our heart, or as I always like to think of it, as a plumber's crack. Right? And then you can see we go to the third quadrant and we continue through, and now we're done. Okay. So kind of matching what we did when we graphed this by hand. Of course, you can play it and let it do all that itself if you want. And you get some nice little fun animations there if you want. That's up to you. Okay? But that way you can actually see how the graph is coming about. So there's our r equals cosine theta plus 1. Okay? Let's continue and look at our second example that we graphed, which ended up being that circle, 2 sine theta. So let me just go in and look at the graph there of 2 sine theta. Okay, zoom out a little bit here. And then you can see we have that circle. Now you can see also, of course, as we go through, 0, and actually we finish the graph at pi. We actually don't see anything more graphing because it's already done. All right, so this actually graphs fully as we get to 0 to pi. Now, if we throw in like a pair of absolute value bars around this, you'll actually see what was happening with that second part of the graph. First part, there's our graph. And now my negative part would have been down here, but again, what's happening is it's actually, because it's negative, it's actually being reflected back around. And there we are. Okay? So that can also help you see what it was doing when it was negative. Okay, but ours was positive there, so we won't bother with that. And then finally, the last one we looked at, R equals 2 cosine of 3 theta. So let's just put that in here now. 2 cosine of 3 theta. Of course, you can see the shape there. And again, we can piece through the graph. So there you are. Starts at 0, pi over 6. And again, it's negative, so it's going to reflect it back through. And you can again see that when we reach pi, we've actually gotten the whole graph. Again, everything else is just repeating on itself. But we could again see what's happening if we did R equals absolute value of 2 cosine 3 theta. And if I add my same parameter A in there, you can see what's happening here. You get your first piece, the next piece is coming down, but again, it would have occurred over here, but again, because of it negative, it reflected back through. And we keep going. It's actually where it's at. Green and black line together. Now the green comes over here, but the black is, of course, absolute value would have been over here, but it's reflected back through. And then, of course, the rest is just going to be the black graph. There it is. It hits its next part. Okay. The next part would have been reflected through, which would have matched back up, and you can see the whole graph. And let me just do one more here with these. Let's make these 2 thetas here, so you can see how you get the 4 petaled rows. Let me just first graph it with the green graph. Right, there's your first petal. There's your 4 petaled rows. Let's watch how the graph happens with the black one here. First one, of course. Notice that every one of the black ones here corresponds exactly with one of the green ones. And it does take the full 2 pi for the green graph to finish. And that's why absolute value in this case is actually the same graph. Okay. All right, so this is just a little introduction to graphing with technology. We're going to do a few other ones that I want to show you as we turn around and look at some graphs here. Okay, so we're going to take a look at some more examples of some graphs that are really kind of interesting and cool looking that we can get with technology that we would just be hopelessly lost with if we were just graphing things by hand.